Okay, good morning, my dear students. Last class we have good morning, my dear students. Last class we have discussed about the air compressors. Okay, we have discussed about the air compressors. In this air compressors, we have discussed about what is compressor, and also we have discussed what is the main function of this compressors. Okay, main function of this compressors, and also we have discussed about the classification, and we also discussed about the what are the types of operations and number of stages, and based on acting capacity of compressor and etc. And we have discussed about the reciprocating compressor. In that we have discussed about the working of single acting reciprocating compressor, and also we have discussed about the work required in single stage compressor without clearance. Okay, also we have discussed the formula of work done. Okay, and also we have discussed about the polytropic process. Okay, PV power N equal to C, and also we have discussed about the power required to drive the compressor. Okay, now let's see the problems in this single acting reciprocating compressor. Okay, first we will see a small problem. Okay, in this you can see the question. Okay, you can see on my screen, you can see the question. A single stage reciprocating air compressor is required to compress 80 meter cube of air from 1 bar absolute to 10 bar absolute. Okay, pressure, it's a pressure. Okay, and he also again asked to find out the work required. Find the work to be supplied if the law of expansion is PV power 1.25 is equal to constant. Okay, that is a given question. Okay, in this okay, first we will write the given data. Okay, first he has given the volume. He has given the volume. Okay, okay, he has given the volume. Okay, first we will see. Okay, first he has given the volume. He has given the volume. Okay, in this first he has given the volume. He has given 80 meter cube of air from 1 bar, that is 1 bar absolute, the pressure to 10 bar. He has given 10 bar. Okay, find the work is applied if the law of expansion is PV power 1.25 is equal to constant. Okay, let's see the solution for this given problem. Okay, if we should find out the work done, we should find out the work done. Okay, we should find out the work done. Okay, we should find out the work done. Okay, first we will write the given data. Given data, he has given air required. First he has given the air required to compress. That is V1 is equal to 80 meter cube. He has given V1 is equal to 80 meter cube, and he has given the initial pressure. He has given the initial pressure. What is the initial pressure? P1 is equal to, that is 1 bar. P1 is equal to 1 bar. Therefore, we will change this. We'll change the units. P1 is equal to 1 into 10 square kilonewton per meter square. Okay, also he has given the delivery pressure. He has given the delivery pressure. That is P2 is equal to, that is 10 bar. P2 is equal to 10 bar. What happens? That is P2 is equal to 10 into, what happens, 10 square kilonewton per meter square. Okay, and he has given the law of expansion. That is law of expansion. law of expansion he has given, what is it given? He has given PV power 1.25 is equal to constant. He has given PV power 1.25 is equal to constant. P power 1.25 is equal to constant. Okay, now what happens? We know work required to drive the compressor. We know what is it? Work required to drive the compressor. Work required to drive the compressor. What's the formula? That is W is equal to N by N minus 1 P1 V1, that is P1 V1 whole to the power of, that is P2 by P1 whole to the power of N minus 1 by N minus 1, that is N by N minus 1 minus 1. This is the formula for the work required to drive the compressor in a single stage reciprocating ink compressor. Single stage, we know we have the given data. What is the given data? We have the N is equal to 1.25. N is equal to 1.25, and from above data we know P1 is equal to 1 into 10 square kilonewton per meter square. And we also know the P2 value. P2 is equal to 10 into 10 square kilonewton per meter square. And also we know the V value. V has given the air required to compress, that is V1 is equal to what is the value V1? That is 80 meter cube. Okay, let's just put all the values in the above equation. We will put all the values in the above equation. We will put all the values in this above equation. Okay, what happens? W is equal to, that is what is the N value? 1.25 by 1.25 minus 1. 1.25 minus 1, that is what is the P1? P1 is into 1 into 10 square. 1 into 10 square into 80 into the bracket open, that is small bracket, that is what is the P2 value? 10 into 10 square by 1 into 10 square whole to the power of, that is 1.25 minus 1 by 1.25 minus 1. There is a bracket close. Okay, after solving this equation we will get W is equal to, that is a 2339, that is a 5.7, that is a 7 kilojoule per cycle. Okay, this is the work done. This is the work done to drive the compressor. Okay, once again I will explain you what is the given data. Okay, a single stage reciprocating air compressor is required to compress 80 meter cube of air from 1 bar absolute to 10 bar absolute. Find the work to be supplied if the law of expansion is PV power 1.25 is equal to constant. Okay, he has given that the compressor, the volume is about 80 meter cube of air, and the pressure will be from 1 bar to 10 bar. Okay, he asked to find the work done. If the law of expansion PV power 1.25 is equal to constant. Okay, we have written the given data. Given data is that air required to compress is V1 is equal to 80 meter cube, and the initial pressure P1 is equal to 1 bar. Okay, we are converting the bars into the Newton per meter square. Okay, because the volume is in meter cube, so we should convert the pressure. Okay, that will is equal to P1 is equal to 1 into 10 square kilonewton per meter square, and the delivery pressure, nothing but there is initial pressure P1 and the delivery pressure is P2, nothing but the exist pressure. We can say exist pressure, that is P2 is equal to 10 bar, and we have converted that into Newton per meter square, kilonewton per meter square. Okay, that is equal to 10 into 10 square kilonewton per meter square. According to the law of expansion, P power 1.25 is equal to constant. Therefore, the N value becomes N is equal to 1.25. Okay, therefore we know the work done formula. We have studied in the last class. Okay, I have told you the derivation also of this work done. Okay, that is W is equal to n by n minus 1 P1 V1. Okay, or the bracket open of P2 by P1 of n by whole to power of n minus 1 by n whole minus 1. That is the formula for the work done. If we substitute the given values in the above formula, we will get that is W is equal to 2.3395.7 kilojoule per cycle. Okay, this is the way of solving the problem. Okay, next we will see another problem in the same way. Okay, in same way we will discuss another problem. Okay, let's see a small problem. Okay, let's see a small problem. Okay, you can see the question. Okay, right. Okay, let's see the question. Let's see this question. Okay, this is the question. Okay, question is, okay, find the work required. Find the work required to compress. Find the work required to compress 1 kg. Find the work required to compress 1 kg of air at 27 degrees. 1 kg of air at 27 degrees in a single stage reciprocating compressor isothermally from 1 bar to 4 bar. From 1 bar to 4 bar. Okay, he asked you to find out the work required. He asked you to find out the work required. Okay, that is isothermally. Okay, that is isothermally. That is a from 1 kg. Okay, let's do the solution. Let's do the solution. Okay, first we will write the given data. First we will write the given data. He has given he has given the kg, nothing but he has given the kgs. Okay, that is another mass. There is a mass is equal to, that is 1 kg. He has given mass is equal to 1 kg, and he has given the initial pressure. He has given the initial pressure. Initial pressure P1 is equal to how much? 1 bar. P1 is equal to 1 bar. Okay, if we convert this into, that is a P1 is equal to 1 into 10 square kilonewton per meter square, and he has given the temperature. He has given the temperature also. He has given the temperature. Temperature, that is a T1 is equal to, he has given, what is the given? He has given temperature, that is 27 degrees. He has given 27. Okay, we should convert into Kelvin. That is T1 is equal to 27 plus 273. 27 plus 273. What will be the T1? T1 is equal to 300 Kelvin. 300 Kelvin. Okay, we know isothermally. What is isothermally? Isothermally compressed in single stage. Yeah, he has said that in the question he has given, that is isothermally compressed in single stage. Isothermally compressed in single stage. That is, we know isothermally compressed in PV is equal to constant. That is, PV is equal to constant. Okay, PV is equal to constant. Okay, PV is equal to constant. Okay, what happens? He has also given the exit pressure. He has given the exit pressure, that is 4 bar. He has given the delivery pressure. Think about the delivery pressure. He has given the delivery pressure. That is P2 is equal to 4 bar. Okay, what happens in this? Nothing but that is P2 is equal to 4 into 10 square kilonewton per meter square. P2 is equal to 4 into 10 square kilonewton per meter square. What happens? That is a P2. Okay, now let's see we know work required to drive the compressor. Nothing but the work required to drive the compressor, work required to drive the compressor. Okay, what happens here? That is a formula, that is W is equal to mr T1 log base C R, mr log base C R. This is the formula. Okay, this is the formula. Okay, what is R? Okay, what is the R? R is nothing but there is a R for R. Okay, we know the R value. R is equal to, that is a 0.287 kilojoule per kg Kelvin. This is R, capital R, smaller. Okay, what happens? That is and here small r is equal to, small r is equal to nothing but the P2 by P1. There is a P2 by P1, that is equal to P2 by P1. That is equal to the V1 by V2. That is a smaller V1 by V2. What happens? There is a R is equal to, what happens? R, this is R. Therefore, what will be the formula? W is equal to mr T1 log base E, that is P2 by P1, log base E P2 by P1. Okay, substitute the given values in this formula. That is W is equal to, what happens? 1 into, what's the R value, universal gas constant 287, 0.287 into, what's the temperature? 300 into log base E 4 into 10 square, there is a pressure, and 1 into 10 square, there is a P1. Okay, what happens here? If we what happens here in this? Okay, if we solve this problem, that is a W is equal to 119.36 kilojoule will be the answer for this problem, above given problem. Okay, in this way we will solve this problem. Okay, now once again I will explain you the problem. Okay, find the work required to compress 1 kg of air at 27 degrees in a single stage compressor, single stage reciprocating compressor isothermally from 1 bar to 4 bar. Okay, in this we should find out the work done. Okay, let's see the given data. There is a given the mass 1 kg and the initial pressure P1 is equal to 1 bar, that is 1 into 10 square kilonewton per meter square, and is given the temperature T1 is equal to 27 degrees, and we will convert it into Kelvin, that is 300 Kelvin, and has been isothermally compressed in a single stage, that is PV is equal to constant. Okay, next he has given the pressure, delivery pressure P2, that is a 4 bar, is a 4 into 10 square kilonewton per meter square. Okay, work required to drive the compressor is W is equal to mr T1 log base C R. The R will be P2 by P1, that is equal to V1 by V2. Then R is the universal gas constant, so 0.287, and when we substitute the given data in this problem, we'll get the work done will be 119.36 kilojoule. Okay, this is a way to solve this problem, and we will see another problem. Right? Okay, just wait a minute. Okay, we'll see one different problem. Okay, okay, right. Okay, we'll see another problem. Okay, just a minute, we'll see one more problem. Okay, right. Okay, we'll see another problem. Okay, right. Okay, this is another problem. Okay, okay, right. Okay, let's see the problem. Okay, this is given. You can see the given question. A single single acting air compressor has a diameter of 180 mm, has a diameter of 180 mm, the diameter of 180 mm, and a stroke of 300 mm, and a stroke of 300 mm, and the air is taken into the cylinder at a pressure of 2 bar, and a pressure of 2 bar and 20 degrees. Okay, it is compressed adiabatically, to 8 bar. It is compressed adiabatically to 8 bar. Calculate the theoretical power. Okay, he asked to find out the theoretical power to require to drive the compressor. Okay, if it runs at 180 rpm, if it runs at 180 rpm, and the mass of air compressed per minute, he has to find out the mass. Okay, he has given the he asked to find out the theoretical power required. Okay, in this, first we should find out the mass also. We should find out the mass of air taken into the cylinder, and we should find out the work done also. Because why should we find the work done? Because the power formula is the theoretical power P is equal to Wn by 60. Okay, first we will write the given data for this question. Okay, right? Okay, solution. We'll write the solution for this. Okay, solution. Okay, first we'll write the given data. Okay, in this given data, first he has given the cylinder diameter, nothing but we can say as bore. Has given the bore D is equal to, that is 180 mm. That is equal to, we'll convert it into meters, that is nothing but the 0.18 meter. And he has given the stroke. Stroke L is equal to, he has given 300. L is equal to 300 mm. That is equal to what happens? 0.3 meter. And he has given the initial pressure. What is the initial pressure? P1 is equal to, that is 2 bar. That is equal to what happens? That is equal to 2 into 10 square kilonewton per meter square. 2 into 10 square kilonewton per meter square. And he has given the temperature. That is T1 is equal to, he has given 20 degrees. That is equal to what happens? 20 plus 273. What happens? That is T1 is equal to 293 Kelvin. That is temperature is equal to 293 Kelvin. Okay, and he has given the pressure. Has given the, what do we say, delivery pressure. We can say has given the delivery pressure. That is we can say as delivery pressure. That is delivery pressure. Has given the delivery pressure. That is P2 is equal to how much? 8 bar. Has given the 8 bar. That is equal to what happens? 8 into 10 square kilonewton per meter square. And he has given the law of compression. That is, he has given, what is given? Law of compression. Law of compression. In which way he has given? Adiabatically. He has given adiabatically. Therefore, what is the formula for adiabatically? That is PV power 1.4 is equal to constant. PV power 1.4 is equal to constant. Therefore, what is the n value? That is 1.4. What is the n value? That is 1.4. That is the n value will be 1.4. Okay, and he also given the speed. He has given the speed n is equal to 180 rpm. 180 rpm. Okay, 180 rpm. Right. Okay, first we will find out the first we will find out the mass of air. First we will find out the mass of air taken. Mass of air taken into cylinder. Mass of air taken into cylinder. Okay, we know what we know, that is a P1 V1 is equal to P1 V1 is equal to MR T1. P1 V1 is equal to MR T1. Okay, we don't know the volume. We don't know the volume. First we will find out the volume. We'll find out the one. Okay, first actually what this formula will be, M is equal to, okay, M is equal to what happens, M is equal to P1 V1 R T1, P1 V1 R T1. Okay, first we will find out the volume. Volume is equal to V1 is equal to pi by 4 d square into the length. V1 is equal to pi by 4 d square into L. Okay, that is equal to V1 is equal to pi by 4. We know the diameter has given in the above diameter, that is 0.18 meter. That is 0.18 meter, and we also know the length, that is 0.3 meter. You know the that is diameter is 0.18 square into the length is 0.3. Okay, 0.3. Okay, we will see here. Okay, what will be the volume? V1 is equal to, that is 0.0076 meter cube, 0.0003 meter cube. Okay, let's go to the problem. In the above problem, okay, what we know, that is M is equal to P1 V1 by RT1, P1 V1 by RT1. That is M is equal to, we know the initial pressure P is 2 into 10 square. It is P1 is equal to 2 into 10 square into the, we know the volume. The volume is 0.0076 divided by, we know the R value, universal gas constant, that is 0.287 into the, what is the temperature, 293. Okay, when we solve this, we will get M is equal to 0.0818 kg, 0.818. This is the mass. Okay, this is the mass, that is the mass taken, the mass of air taken into the cylinder. This is the mass of air taken into the cylinder. Now we will find out the work done. We will find out the work required. We will find out the work required. Work required to drive the compressor. That is W is equal to, gamma by gamma minus 1 P1 V1, that is P2 by P1 whole to the power of gamma minus 1 by gamma whole minus 1. This is the formula. Okay, gamma adiabatically, that is if adiabatically gamma is equal to 1.4. Okay, let's substitute the given values, that is W is equal to 1.4 by 1.4 minus 1 into the 2 into 10 square into the, we got the volume, that is 0. Here the volume 0.0076 into that is, that bracket open, that is 8 into 10 square by 2 into 10 square, that is whole to the power of 1.4 minus 1 by 1.4 whole minus 1. Okay, whole minus 1. Okay, if we solve this above equation, we will get W is equal to 2.585 kilojoule per cycle. 2.5 kilojoule per cycle. Okay, this is the way of solving the problem, and the problem is not over. He asked to find out the theoretical pressure. He asked to find out the theoretical pressure. He asked to find out the theoretical pressure, theoretical power, theoretical power required, theoretical power required, that is the P is equal to Wn by 60. P is equal to Wn by 60. Okay, P is equal to Wn by 60. Okay, we know the work done. Now the work done, that is P is equal to, what is the work done? 2.585 into, what is the N? N is 180 by 60. Okay, P is equal to 80 by 60. Therefore, P is equal to, that is 7.755 kilowatt. Okay, this is the problem for the solution. This is the theoretical power required to drive the compressor. Okay, once again I will explain you this problem. Okay, let's see from the starting. Okay, he has given the question as a single cylinder single acting air compressor has cylinder diameter of 180 mm and a stroke of 300 mm. Air is taken into the cylinder at a pressure of 2 bar and 20 degrees. Okay, it is compressed adiabatically. Okay, this will be N or gamma. It will be gamma or N. It will be gamma or N, gamma 1.4, and has given adiabatically to 8 bar. Calculate the theoretical power required to drive the compressor if it runs at 180 rpm and the mass of air air compressed per minute. Okay, ask you to find the mass and ask you to find the theoretical power. Okay, gamma because it adiabatically. Right, we'll note down the given data first. That is a bore has given the diameter D is equal to 180 mm, that is equal to 0.18 meter, and has given the stroke, the length L is equal to 300 mm, that is equal to 0.3 meter, and also given the initial pressure P1 is equal to 2 bar, that is 2 into 10 square Newton per kilonewton per meter square, and is given temperature T1 is equal to 20 degrees. Okay, we will convert into Kelvin, that is 220 plus 273, that is T1 is equal to 293 Kelvin, and he has given the delivery pressure P2 is equal to 8 bar, that is equal to 8 into 10 square kilonewton per meter square, and he also given the law of compression. He has given the law of compression in the question, that law of compression is adiabatically, therefore P per 1.4 is equal to C, therefore gamma is equal to 1.4, and he also given the speed N is equal to 180 rpm. Okay, now we'll find out the mass of air compressed. That is we know the formula P1 V1 is equal to MRT1. Therefore M is equal to P1 V1 by RT1. Okay, we don't know the volume. Okay, volume V1 is equal to pi by 4 d square into length. Okay, we know diameter and we know the length in the given data. There is a V is equal to pi by 4 0.18 whole square into 0.3. Okay, we'll get the that is volume is equal to 0.0076 meter cube. Okay, after that we will substitute the given values in the above equation, that is M is equal to P1 V1 by RT1, that is M is equal to 2 into 10 square into 0.0076 divided by 0.287 into 293. Okay, we will get the mass, that is the mass M is equal to 0.0181 kg. Okay, we know the formula for the work required to drive the compressor. W is equal to gamma by gamma minus 1 P1 V1, the bracket open, P2 by P1 whole to the power of gamma minus 1 by gamma whole minus 1. Okay, we will substitute the values, we will get the work done is equal to 2.585. okay, and the theoretical power is P is equal to Wn by 60. That is we know the work done and we know the speed, and therefore the power will be 7.755 kilowatt. Okay, this is the problem. Okay, and we will see another different type of problem regarding the what we say different types of I have said the isothermal compression, and we have said the compression law, and we have the adiabatic compression. We'll see another problem. Okay, let's see one another problem. Okay, in this we can see all process. Okay, let's see the question. Okay, a single stage single acting air compressor 30 centimeter diameter and 40 centimeter stroke makes 100 rpm. It takes air at 1 bar and 20 degrees and compresses it to pressure of 5 bar, and asked to find the work done in isothermal process, and PV for 1.2 is equal constant, and the last is the adiabatic, and also adiabatic compression. He asked to find the ABC in this. Okay, first we will write the given data. Solution. Okay, first we will write the given data. Here is given data. Okay, he has given the diameter of cylinder. Is equal to D is equal to, that is 30 centimeter. We convert to meter, that is 0.3 meter. And he has given the stroke. Stroke L is equal to, he has given 40 centimeter. That is equal to 0.4 meter. He has given 0.4 meter. And he has given the volume. Okay, and he has given the and we will find the volume. Okay, afterwards we will find. First we will write the given data, and has given the speed, speed n is equal to how much, 100 rpm, and we will find, and he has given the initial pressure. Initial pressure P1 is equal to how much? It is a 1 bar, that is equal to 1 into 10 square kilonewton per meter square. Okay, right, and has given the final pressure or delivery pressure. We can say final pressure or delivery pressure. That is the P2 is equal to how much? That is 5 bar. That is equal to 5 into 10 square kilonewton per meter square. Okay, and this is the given data. Okay, first we will find out the mass. First we will find out the volume. We will find out the volume. V1 is equal to pi by 4 d square into length. Therefore V1 is equal to pi by 4 into, what is the diameter of cylinder? That is 0.3 meter. So 0.3 whole square into, what is the length? That is 0.4. Okay, we will get by substituting, that is a V1 is equal to 0.0283. That is a meter cube. 283 meter cube. This is a given volume. We will find out the next. We will find out the mass. We will find out the mass of air. That is P1 V1 is equal to MRT1. Okay, what will be the M is equal to? It is a P1 V1 by RT1. That is M is equal to, what is the initial pressure? There is a 1 into 10 square into, what is the volume? 0.0283 by, you know, the 0.287, this is a constant, into 293. Actually, has given the temperature. But we did not write here the temperature. There is a, we will write here that the temperature T1 is equal to, I have forgotten, T1 is equal to 20 degrees, that is 20 plus 273 is equal to 293 Kelvin. I have forgotten to write the temperature. He has given the temperature 20 degrees. Okay, he has given the 20 degrees the temperature. I have forgotten. Okay, that is the 293. That is M is equal to, what will be the M is equal to? What happens? That is a 0.0336 kg. 0.336 kg. Okay, this is mass. Okay, we will find out, first we will find out isothermal. First we will find out A. What is that? It is isothermal compression. First we'll find out the isothermal compression. Okay, in this isothermal compression, what is the work done? What is the work done? Work done is equal to mr T1 log base E, that is P2 by P1. Okay, this is the formula. Therefore, W is equal to, if we substitute the given data, W is equal to, what happens, that is 0.0336 into, that is 0.287 into temperatures 293 into log base E, that is 5 into 10 square and 1 into 10 square. Okay, what will the work done? That is W is equal to the substituting, what will get 4.55 kilojoule. Get 4.55 kilojoule. Okay, next we will find out the B. We will find out the B. Asked B, what we asked, compression law. It is a PV power 1.25 is equal to constant. P power 1.25 is equal to constant. So what will be the work done? It is the work done is equal to n by n minus 1 mr T1, it is a P2 by P1 whole to the power of n minus 1 by n whole minus 1. Okay, what happens? W is equal to, what is the n value? 1.2 by 1.2 minus 1 into, what is the mass? 0.0336 into 0.287 into 293 bracket open, that is 5 into 10 square by 1 into 10 square whole to the power of 1.2 minus 1 by 1.2 minus 1. Okay. Okay, after solving this equation, we get W work done. W is equal to 5.22 kilojoule. 5.22 kilojoule. Okay. Okay, this is and last he asked the C1, he asked the adiabatic compression. He asked the adiabatic compression. Okay, adiabatic compression, what do we know? PV per gamma is equal to constant. PV per gamma is equal to constant. What happens for gamma? What is the gamma? Gamma value 1.4. Gamma is equal to 1.4. Gamma is equal to 1.4. Let's substitute the value. The same formula. N will be replaced by gamma. Work done. W is equal to, that is gamma by gamma minus 1 mr T1 of P2 by P1. Gamma minus 1 by gamma whole to the power of minus 1. Okay, whole to the power of minus 1. Okay, let's substitute the given values. W is equal to, that is 1.4 by 1.4 minus 1 into 0.0336 into 0.287 into 293, that is 5 into 10 square by 1 into 10 square, 1.4 minus 1 by 1.4 minus 1. Okay, the work done, W is equal to, that is 5.77 kilojoule. Okay, this is the way of solving the problem. Okay, I will once again tell you the problem. Okay, a single stage single acting air compressor 30 has a 30 cm diameter, 40 cm stroke, makes 100 rpm. It takes air at 1 bar and 20 degrees. It takes air at 1 bar and 20 degrees and compress it to a pressure of 5 bar. Okay, compress it to a pressure of 5 bar. I asked the work done in isothermal and P power 1.25 is equal to constant, and he also asked the adiabatic compression. Okay, first we will write the given data. Is given the diameter of cylinder D is equal to 30 centimeter. We will convert it into the meter, 0.3 meter, and he asked the stroke L is equal to 40 centimeter, that is 0.4 meter, and he has given the speed N is equal to 100 rpm, and he has given the initial pressure P1 is equal to 1 bar, that is 1 into 10 square kilonewton per meter square, and is given P2 final pressure 5 bar, and also given the temperature, that is 20 degrees, that is 293 Kelvin. Okay, first we'll find out the volume, that is V is equal to pi by 4 d square into length, and we'll get the volume V is equal to, after substituting we'll get 0.0283 meter cube, and we'll find out the mass of air. There is a P1 V1 is equal to mRT1. If we M is equal to P1 V1 RT1, and the M will be 0.0336 kg. Okay, if we will go to the main problem, that is of work done. There is work done isothermal compression. In this isothermal compression, the work done will be mRT1 log base E P2 by P1. After substituting, we'll get 4.55 kilojoule per kg. And the compression, has given the compression P power 1.25 is equal to constant. The work done will be N by N minus 1 mRT1 P2 by P1 of N minus 1 by N minus 1. After substituting, we'll get W is equal to 5.22 kilojoule. And at last, he has given the adiabatic compression. We know adiabatic P power gamma is equal to constant, therefore the gamma value will be 1.4, and we will know the work done W is equal to gamma by gamma minus 1 mRT1, that is P2 by P1, gamma minus 1 by gamma minus 1. Okay, after substituting, we'll get 5.77 kilojoule. Okay, so the following problems in the single stage single acting air compressor. Okay, remaining problems we'll discuss in the next class. Okay, thank you very much. Okay, and solve the remaining worked out examples. Okay, thank you very much.